In part 1 of this 2-part video series, we analyzed together the basic design principle of audio in video games and the limitations of current audio solutions in reproducing audio of video games in an immersive and realistic manner. And in this second and final part of this video series, we're going to analyze how Sony created the 3D audio for the PlayStation 5 and the potential and real impact of the 3D audio in the PlayStation 5. Oh, and I would also recommend you use your favorite headset when watching these videos to maximize your experience. Also, I'm really sorry about the long delay in publishing this second part of this video series, which was originally supposed to be published within a week or two from part 1. Unfortunately, my PC decided to die at the worst possible time, and I was also busy shifting recording location, but it did give me an excuse to build this awesome new powerful PC. Anyway, back to the analysis. How does Sony plan to deliver the 3D audio experience on the PlayStation 5? Well, first they needed to measure and capture the HRTF data needed to create 3D audio. A special, extremely quiet audio room is constructed that is highly sound absorbent to prevent the reflection and bouncing of sound waves around, and this is achieved by using custom-made, high-quality sound-absorbing panels. Then, a large array of speakers is installed in a fully spherical or semi-spherical arc around a rotatable chair in the middle of this setup. The subject, or essentially the player, is placed in the rotatable chair while also installing small microphones inside both right and left ears, just at the entrance of the ear canal. Let's use the following simplified diagram, which mimics the actual real-life setup with the array of speakers and the subject sitting in the rotatable chair in the middle, along with the tiny headphones that are installed inside the subject's ears. The speakers are installed at a specific predefined distance and at specific predefined angles, or essentially sound locations, relative to the subject's listening position from the speaker. Then, an audio sweep that spans a very wide range of audio frequencies is played from each speaker around the subject. The idea here is that the speakers are simulating the sound that would be emitted from different types of audio sources or sound objects that are placed at various angles or locations around the player, as they would be in real life. As the audio is played, the auditory data is sampled and measured using the tiny microphones that are installed inside the subject's ears. This is to accurately capture how this person is hearing these different sounds as the sound waves enter and bounce off the outer ear's bumps and falls, which slightly alters the frequency and the phase shifts before entering the inner ear canals, as we saw in part 1. So we are essentially capturing exactly how this particular person hears the different sounds around them as they would in real life. And it doesn't end here. The subject is then rotated around the vertical axis at very small angle increments on the rotatable chair, typically by 0.1 to 5 degrees. And the same process is repeated once again, but this time the listening position has changed ever so slightly. This is to simulate if the player moved around relative to the sound source. And since the player's listening angle has changed slightly now from last time, the audio from the sound source or the speakers would sound slightly different compared to the previous listening angle. Just like in real life, if you hear some sound and then you turn your head slightly, the sound would sound a little bit different. And this new auditory data is sampled and measured. The process is repeated until a comprehensive 360-degree cycle is completed, which could take on average 10 to 20 minutes per person, possibly longer in different variations of this setup and depending on the targeted data resolution. The ultimate result of this process is the measurement and creation of a comprehensive and very precise HRTF profile of the subject, with over 1,000 sampled HRTF audio locations around the player for a very wide range of frequencies, or essentially sound sources, and virtually all locations around. This profile is what is also known as the HRTF table that Mark Cerny referred to several times in his presentation due to its importance. And as we analyzed in part 1 of this video series, HRTF is the relation between how the ear receives and translates the sound emitted from a sound source, which is unique per person as it depends on the particular shape and size of the head and ears of each person. Therefore, we now know almost precisely how this particular person would hear a sound in real life from different sound sources at different angles or locations around them, and the 3D audio could be simulated very accurately and realistically to this person. With this newly measured HRTF data, game developers are now able to create an accurate and realistic 3D audio experience experience. And although the basic principle of this HRTF measurement process might seem relatively simple in principle, keep in mind that this process requires a sophisticated and expensive equipment and audio computing infrastructure to measure the HRTF data accurately and to compensate for other audio factors during the capture process and so on. Also, it's worth noting that there are different variations of this process, most commonly the use of a half-spherical arc of speakers instead of full arc, or even multiple arrays or arcs of speakers as we saw in the screenshots, or sometimes using only a single speaker that moves spherically around the subject, and so on. Mark Cerny explained that Sony's primary focus is to launch 3D audio first for headphones on the PS5, with potential future plans to introduce 3D audio to stereo or TV speakers, possibly even surround sound systems, but no specific timelines or commitments. And now for one of the coolest parts in this video, let's experience together what the 3D audio experience on the PlayStation 5 could sound like, referencing Mark Cerny's example about the ability to distinguish individual raindrops around the player. Put on your favorite set of headphones, any headphones should do, and listen to the following audio clip. And here's another test from another popular 3D audio clip from many years ago, just to give you another example of how the experience could sound like on the PlayStation 5.
Oh, hello there, how are you? Yes, you are here for the virtual haircut? He is coming up right now, and meanwhile I will go over here and...
If you just hold still for a second, I'll put this bag over your head. Just like that. Let me finish washing my hands here. Just bear with me for a few more seconds. Your brain is doing all of the work. To the left ear. I'll first bring it close to your right ear. Is it perfect? And around the back. Well, thank you.
So what do you think? I think it's quite a remarkable audio experience. Let's now go back to the practical game example that we analyzed in part 1 of this video series that had multiple sound sources in it. Now with the newly measured and processed HRTF data, the game audio design expands and transforms from being a simple speaker or channel based placement of sound sources to a more accurate and realistic object-based placement of the sound sources around the player. This vastly expanded 3D audio is thanks to the thousands of sampled HRTF locations from the process that we analyzed earlier, and it's a completely transformative approach from traditional game audio design. Therefore, now each water or raindrop could be treated as an individual audio object that is falling at different locations or angles around the player, rather than just a simple single flat audio file for the whole rain audio effect. Likewise, each leaf could now be treated as an individual audio object that is blowing in the wind around the player at different locations. And finally, that pesky golden bird could be placed much more accurately around the player, rather than just playing its sound from a general channel direction. So that Jin doesn't miss a single hot spring, I guess. But more importantly, the audio characteristics and position of each audio object can now be manipulated separately and independently, enabling far more degree of accuracy and control for the game developers over the audio design, with the ability now to literally distinguish and differentiate each individual leaf blowing in the air around us, from the high to the low leaves to the ones flying in our face or behind us, and distinguish each water drop that is separately falling around us at different angles, similar to the 3D audio clip that we heard earlier, but to a higher level of realism. With this new level of audio design, gamers will get much closer to feeling both the presence and locality of audio in games to achieve a much higher level of immersion. Or at least that's how it's supposed to work. Keep in mind that due to technical and practical design limitations, it's not necessary that every sound source could be treated as individual 3D audio object. For example, perhaps only the raindrops and leaves that are falling directly on you would be treated as individual audio objects, while those raindrops and leaves that are further away would be treated as flat audio files. In most cases, I believe it would be similar to the output of VR audio engines, where it's a combination of both speaker and object-based placement of audio to create a sophisticated audio experience. Alright then, the prospect of 3D audio on the PlayStation 5 sounds very promising and thrilling. However, there is a set of technical challenges that is very important to analyze and understand. As we saw in part 1 of this video series, HRTF data is largely dependent on the physical characteristics of each person, the shape and size of the head and ears, which naturally differs from one person to the other, which means that each one of us would require their own custom HRTF profile to experience 3D audio realistically, which is of course not feasible to do. However, Mark Cerny did emphasize on the importance of having a closely matching HRTF profile to get a convincing 3D audio experience by giving an example. When he was playing a game using the default HRTF, the audio experience was decent, but when he switched to his own custom HRTF, he reached a new level of 3D audio immersion. And to solve this problem, Sony performed the HRTF measurement process on hundreds of subjects in an effort to create a wider HRTF pool with varying shapes and sizes of head and ears. And the engineering team analyzed and processed the data to come up with the 5 different HRTF profiles with which the PS5 ships with today. And you can perform a simple test to select the most suitable HRTF profile to you. And although HRTF data differs from one person to the other, there is usually a decent level of resemblance between the different HRTFs for a group of people, and our brain can effectively adjust or fill in the gaps for the most part, or at least to some degree, to match your own HRTF characteristics. Therefore, most players are expected to fall within the 5 HRTF profiles. However, Mark Cerny did clarify that some players might fall outside of those predefined profiles. And to those players, the 3D audio experience might not sound too different from a little bit better stereo audio. Here's hoping you're not one of those unlucky outliers. I personally wouldn't worry too much about it, as there are several 3D audio clips online, and we've already listened to a couple of those that deliver a really good 3D audio experience, and this is without even the more advanced processing solution in the PS5. Which takes me to the next set of technical challenges that are perhaps more challenging, more difficult, and more important to address. In the previous 3D audio clips that we tested, and in almost all the 3D audio clips you find online, the complex HRTF calculations are pre-processed or done in advance, usually using powerful, specialized audio processing hardware. But we do not have this luxury in games, as 3D audio must be performed in real time and by applying complex HRTF calculations in a fraction of a second. For example, the audio object in the game in certain scenes might not be a match to any of the thousands sampled HRTF locations, as it's impossible to capture and sample every HRTF location. And here a process of mixing and computing the closest matching HRTF sampled locations must be performed on the fly and in real time very quickly, which is computationally very expensive and heavy process on the console's CPU or APU that is already very busy processing gameplay and rendering graphics. Likewise, the audio object might be moving around very quickly and changing audio locations very frequently within a very short time frame, requiring extremely fast sub-second processing, or perhaps the audio object or source might be emitted from a large area or direction rather than a single point or position. These real-time HRTF calculations that are critical to the 3D immersion experience are computationally very heavy and expensive, which means that using a general-purpose x86 CPU or APU in a console would not be enough, as it would eat away from the resources required to run the gameplay and render the graphics, and game developers typically favor those over audio design. And here, Mark Cerny explained how the PlayStation 3 beastly cell processor at its time was remarkable in its ability to process complex audio, thanks to its custom powerful SPU cores, while the PlayStation 4's Jaguar processor was based on a mainstream general-purpose x86 CPU architecture, similar to what we have on PCs, that are far from being ideal to process complex audio, which means that when the game runs on the PS4, there's already heavy contention on the resources for gameplay and graphics, leaving at best half a core or a fraction of it to render audio, which is not nearly enough to what 3D audio requires with its complex HRTF calculations. This technical limitation on the PS4 pushed Sony to create a custom audio processing chip in its PSVR virtual reality headset to process 3D audio, since the PS4 cannot do that natively, and 3D audio is critical in VR games. In the same way, this directed Sony to do the same thing with the PlayStation 5 by developing a much more advanced custom audio processing chip that can process hundreds of advanced 3D sound sources.
This was achieved by reverse engineering one of the GPU cores, since its parallelism is more suited than an x86 CPU core, and optimizing it for complex audio calculations to be closer to the SPU cores of the PS3's cell processor. And the result is what Sony calls the Tempest 3D Audio Tech, a dedicated hardware and software audio processing unit in the PS5 designed specifically to deliver not only enhanced audio experience, but primarily a realistic and immersive 3D audio experience. In fact, the PS5 Tempest Engine is so powerful that it has the SIMD processing bandwidth for audio equaling all the 8 cores of the PS4 CPU, which should give you an idea of how powerful this engine is.
You might recall from the intro of part 1 of this 2-part video series when I said that this is the return of one of the coolest technologies in video games.
And that's actually quite true, because 3D audio had previously existed on PCs in the 90s until around the mid or end of 2000s, thanks to the popularity of sound cards in PCs back in the day that were specialized in processing advanced audio such as spatial or 3D audio.
Technologies back in the day such as Direct Sound 3D, OpenAL, EX Advanced HD Audio, and even all the way back to A3D with its wave tracing, yes, wave tracing, were all able to deliver truly remarkable 3D spatial audio experience thanks to the popularity of PC sound cards back in the day. Now, unfortunately, PC sound cards were dropped or lost popularity, kind of forced out of PCs toward the end of the 2000s for many technical and commercial reasons that I will not dig into in this video, though it could be argued that the primary reason was the way Windows Vista changed access to audio in the operating system and the way it handles hardware acceleration of audio processing. In any case, unfortunately, this led to developers to stop focusing on developing 3D audio in their games because simply most gamers did not have the ability anymore to leverage and make use of 3D audio in their video games.
It's a bit ironic perhaps that with time, processing graphics moved away from relying on CPU and software only to having its own dedicated hardware GPU card, while for processing audio it was the opposite. But what enabled the return of 3D audio was the resurgence and success of virtual reality headsets and VR games, where 3D audio is a critical component of the VR immersion experience.
Other technologies similar to the 3D audio in the PlayStation 5 that we have seen this generation and that have existed for a long time ago, such as binaural audio, in games like Resident Evil 2 and Hellblade: Senua's Sacrifice were actually implemented pretty well. Even games such as competitive games such as Overwatch, PUBG, Fortnite have added support for some form of spatial audio in their games. There are also other technologies such as Windows Sonic and Dolby Atmos for headphones that are able to deliver a decent 3D spatial audio experience.
But all these technologies rely primarily on a software-based virtualization solution for HRTF processing and computed in real time via a general-purpose processor or x86 CPU, which, as we analyzed earlier, is not enough for complex HRTF calculations. So the result is a decent 3D audio, whereas the PS5 uses custom-measured and processed HRTF data that is additionally computed via a dedicated processor specifically for this task, the Tempest Engine, similar to the PC sound cards of the past, to give developers enough processing power to simulate 3D audio accurately. The ultimate result is a new level of 3D audio immersion and realism. Or again, at least that's how it's supposed to work.
Alright then, the golden question to end this video series with is: can Sony deliver on its promise of successfully implementing the 3D audio in the PlayStation 5 to deliver a truly transformative and immersive 3D audio experience the way they are promising us? In my personal opinion, yes, Sony has the capability and the potential to do so.
Keep in mind that Sony is a veteran player in the advanced audio space with nearly 50 years of experience developing advanced audio solutions and devices, with large engineering teams specialized in audio engineering, and they are not new to this kind of spatial audio. A few years back, they had launched their 360 reality music technology, which actually delivers some truly remarkable audio experiences. I'll leave some links for you below to try. But perhaps more importantly, Sony's experience with 3D audio from its highly successful PSVR headset, and we've even seen Sony kind of experiment experimenting with 3D audio with its first-party studios in games such as Uncharted 4, The Last of Us 2, and other games that support 3D audio but require the use of specific headphones like Sony's Platinum headset for the PS4 because it contains a dedicated custom chip that can process advanced 3D audio, since the PS4 cannot do that natively. And it's clear that Sony spent an extensive amount of time and effort in the PS5 development cycle to have a dedicated audio solution baked into the PS5 rather than just bolted on. And perhaps the coolest thing about Sony's vision for audio on the PlayStation 5 is that they want to deliver great audio for all gamers, not only those that have expensively licensed headsets or sound systems. Literally anyone with an ordinary set of wired headphones should be able to enjoy and experience 3D audio on the PS5. I feel it's important to clarify that the PlayStation 5's 3D audio solution is not perfect by any means, at least not at launch, and it's not a magical silver bullet that will result in immersive 3D audio experience in every game and every time. The effectiveness of this technology will depend first and foremost on the game developers' adoption and implementation of 3D audio in their games, which not every game studio has the resources, experience, or even design priority to do so. And Mark Cerny explained that 3D audio is a major academic research that is continuously improving, and Sony is committed to continually improving the experience in this generation. Long story short, I think it would be best to set our expectations realistically, at least early on with this new gaming generation, and be patient as the technology matures and receives wider adoption. History have shown us that if given the choice of using hardware resources between graphics and audio, developers will almost always prioritize graphics over audio. But perhaps now, with the availability of a dedicated complex audio processing solution in the PS5, this would encourage more developers to enhance the audio experience without worrying that the resources are being taken away from graphics and gameplay. Even if it's not 3D audio, just a more advanced audio effect would result in a better experience.
Finally, this 2-part video series is done. Honestly, this video series took a lot of time and effort to produce to the high quality standards that I was targeting, and I hope I succeeded in doing so. I hope you found this video helpful, beneficial, and entertaining, and that you have a better understanding and appreciation of the true potential and real impact of 3D audio in video games, not only specifically on the PlayStation 5. If you like this video, please do leave a like, maybe even a small comment below to help me beat the YouTube algorithms, subscribe to the channel, maybe share the video with a friend or two, help me in spreading my channel, and I'll see you next time, inshallah.